Okay, so yesterday we left off with 5.5 where we started investigating Euler circuits and Euler paths. So yesterday in our investigation we found out Euler circuits have no odd vertices. Okay, so right here this is a key point that you're going to want. Graph is connected and has no odd vertices. Remember, in order for a graph to be connected, there is one big piece that is connected by lines. There are no separate pieces. A Euler path, however, had exactly two odd vertices. Okay, remember, it can't have more than two odd, it can't have less than two odd, it has to have exactly two odd. So, this leads us into today's topic, Fleury's algorithm, section 5.6, which is don't burn your bridges behind you. So, there are two separate facts that we need to know. Fact 1. An edge can only be traveled once in a path or a circuit. You cannot go across the road and back across the road. It's a one-way street. All you can do is go one way. That's it. Once you've traced it, it's burned behind you. That's where the idea and the concept comes from. Fact 2. Certain edges you choose may get you stuck and prevent you from tracing all of the edges without retracing because it's a bridge. Again, once you go across it, if there's no other edge connecting that point, you're stuck. There's nothing else you can do. You cannot travel again. So, in order to use Fleury's algorithm, this is a good way to figure out, do I have a circuit or do I have a path? Which will then in turn help you trace that circuit or path. So, step 1 is we need to determine what I have. Do I have a circuit or do I have a path? So the way we do that is we check the degree of all of your vertices. So we're going to go ahead and we're going to count how many edges come out of each vertex. If they're all even, again, you have a circuit. If you have exactly two odd, you have a path. If you have anything other than those two options, you have neither a circuit nor a path. After that, we need to actually find the circuit and path by numbering the edges like we have been doing. So we have to pick a starting vertex. In a Euler circuit, you can pick any vertex you want to start unless the problem gives you a specific starting point if you have a circuit. The problems we're going to do after this will tell you we need to start at vertex A if you have a Euler circuit. If you have a Euler path, you can pick either one of the odd vertices because remember, you must start at an odd and you must end at an odd. The intermediate steps are the steps that are going to happen in between. As we go across the edges, we're going to label them or number them in order so we know how we've traveled. First, we always choose an unused edge that is not a bridge. We want to try to avoid bridges at all costs. Okay, and that way we don't get stuck somewhere. And then finally, as we're doing our steps, we only choose that bridge if it is our only option at the current vertex. So let's take a look at some examples here. Let me make this bigger so everybody can see. Okay. So the first thing, again, that we have to do is we need to determine if the graph is a path or a circuit or none. So again, we do this by finding the degree of each vertex. Degree of each vertex. Okay, so if you come over to graph 1, A has two lines coming off of it, it has a degree of 2. B has 4 edges coming off of it, it has a degree of 4. C has a degree of 2. D has a degree of 4. E has a degree of 4. F is a degree of 2. G is a degree of 2. So every one of my degrees is even, so this should tell me that I have a Euler circuit. Okay, so now step 2 says find the Euler path or circuit by numbering the edges. Okay, and then below that it says in a Euler circuit, pick vertex A as your start. So let me switch colors here. Okay, so A is going to be my starting point. Remember, if it's a circuit, start equals end. start equals end. So if I start at A, I need to end at A. So I'm going to leave point A and I'm going to travel across to point B. That's going to be my first edge. I'm going to leave B this time. I'm going to travel down to D. That's 2. I'm going to go across here to E. That's 3. I'm going to trace this little triangle up top here first. So there's 4, 5, and 6. Go down to G because I can't retrace any of my steps. So that's 7. Across to F is 8. Up to D is 9. Up to A is 10. So I've started at point A and I've ended at point A. So this is my start and my end. And that's all there is to it. So in graph number 2, let me switch back to my blue here. Again, count your degrees first and determine whether we have a path, circuit, or none. So A has a degree of 2, B has a degree of 2, C has a degree of 1. Notice my edge B to C, that is a bridge. Once I travel to C, I can't go back to C. That is a problem. So we definitely don't have a circuit here. We've got an odd degree. Let's see if we have a path. D is 3, E is 4, F is 2, H is 2, and G is 2. So I've got 2 odd degrees. So this should be a Euler path. Notice I put E circuit and E path because in the next chapter we're actually going to talk about Hamilton circuits and paths, which are a little bit different. Okay, so keep that in mind. There are differences between Euler and Hamilton. We will do other circuits and paths, so you'll need to determine the difference later. Okay, so Euler path. Pick the odd vertex as a start, any odd vertex. So my start has to be odd. My end has to be odd. Okay, so let's start at D and let's end at C. Okay, so I'm going to trace this triangle first over here. So that's 1, 2, 3 edges, and that takes me right back to my starting point. I'm going to trace across to E. Now I don't want to go up to C because these are bridges here. Remember, bridges always are supposed to be my last resort. E to B is a bridge, B to C is a bridge. So I want to do this triangle down here first. So we're going to go down to H, up to F, across to E, up to B, and across to C. Okay, moving on. Graph 3 and graph 4. Okay, so again, step 1, determine what I have. So A has a degree of 4, B has a degree of 2, C has a degree of 4, D has a degree of 4, E has a degree of 2, F has a degree of 2. So everything's even. This is a circuit. Which means A needs to be my starting point because that's the directions that I gave. So I'm going to leave A this time, and I'm going to take this windy road out. So that's 1. Up to C is 2. I'm going to go back up to the starting point. That's 3. Down to D is 4. across to C is 5, down to F is 6, up to D is 7, up to B is 8, and back across to my starting point is 9. So A is my start and my end. In graph number 4, A has a degree of 4, B has a degree of 4, C has a degree of 4, D has a degree of 6, F has a degree of 4, G has a degree of 4. So, again, we've got a Euler circuit. So, we're going to start at A and end at A. This should be my start and my ending. I'm going to travel across to B. That's 1. Here's 2 and 3. Trace that little oval looking thing there. Go down to D, that's 4. Down to G, that's 5. Across to F, that's 6. I'm going to go back to D, that's 7. Over to C, that's 8. Across to F, that's 9. Back to C is 10. Up to A is 11. Down to D is 12. And back to A is 13. Okay. Moving right along, graphs 5 and 6. A has a degree of 2, B is 4, C is 4, D is 2, E is 5, F is 4, G is 4, H is 5, I is 2, J is 4, K is 4, and L is 2. And we've got another circuit. Okay, so we start at A. I'm going to go down to E this time. I'm going to kind of trace the outside edges first. So here's 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh. Can't do that. Back up a step. Can't go 10 there. Okay. Remember, this is now kind of a bridge. Once I go to A, I can't leave A again. So that was my mistake. So now when we leave here, let's go ahead and down to F. And we'll go to the right and trace all of that and then head back towards A. So here's 11 to G. Up to C is 12. Down to H is 13. Across to G is 14. Down to K, ooh. I think I just need to start over. All right. Large eraser. Oh, never mind. I know what our problem is. Did anybody catch it? Four, 4, 2, 5, 4, 4, 5, 2, 4, 4, 2. This isn't a circuit. It should be a path. We've got two odd vertices at E and H. So here's 1, here's 2. Sorry about that. Start and end. Okay, so I need to start at an odd and end at an odd. So let's go up to A, there's 1, across to B, there's 2. Down to E, there's 3, down to I is 4, across to J is 5, back to E is 6. Across to F is 7, here's 8, over to C is 9, down to G is 10, across to F is 11, down to J is 12, across to K is 13, there's 14 up to G, across to H is 15, down to K is 16, across to L is 17, up to H is 18, to C is 19, to D is 20, and down to H is 21. As you noticed, I made a mistake. That's okay. Mistakes will happen, but you have to start learning from them and figuring out where you went wrong. Okay, let's take a look at graph 6. A has a degree of 4, B has a degree of 4. Please note here too, right here and right here, those are not vertices, okay? There are no dots there. Therefore, they're not vertices. These lines are an edge, even though they come out to a point. Also, this middle section right here, that is not a vertex, okay? The lines intersect there. The line goes clear from A to F, from E to B, from C to D. This is not a stopping point. You cannot stop there, okay? All right, C has a degree of 3. Whoops, took my marker away. C has a degree of 3. D has a degree of 3, 4, and 4. So again, we've got a path. So we have to start at one odd, end at the second odd. So let's make D my start point this time. And let's make E my end. Okay, so we leave D. I'm going to go down to F first, and then I'm going to trace this big old line back to B. Again, that's only one edge. Okay, leave B and go back to D. Leave D and go the whole way across to C. That's 4. Go up to A is 5. Way down to F is 6. Across to E is 7. All the way up to B is 8. Across to A is 9. Down to E is 10. And finally we end at C with edge 11. 5 more examples. So here's 7 and 8. A has a degree of 2. B has a degree of 4. C has a degree of 4. D is 2. E is 4. F is 4. G is 4. H is 4. I is 4. J is 4. K is 4. L is 4. M is 2. N is 2. O is 4. I'm sorry, N was 4. Apparently I cannot count today, guys. N was 4. P is 2. So everything is even here. We should have a Euler circuit. Okay, and according to my instructions, I need to start at point A. So we're going to go down to E, that's 1, up to B is 2, down to F is 3, across to E is 4, down to I is 5, down to M is 6, across to N is 7, up to I is 8, across to J is 9, down to N is 10, across to O is 11, here's 12, I'm going to go back to J, that's 13, up to F is 14, across to G is 15, down to K is 16, let's go across to L, there's 17, down to O is 18, across to P is 19, up to L is 20, up to H is 21, let's go up to D, that's 22, across to C is 23, here's 24, across to G is 25, up to C is 26, across to B is 27, and across to A is 28. As they get bigger with more edges and more vertices, the more complex they get. You just really need to take your time and make sure you're paying attention. Okay, graph 8. A has a degree of 4. B has a degree of 3. Oh, we've got an odd, so this probably is a path. C is 4. D is 4. E is 3. There's my second odd. And F is 4. So we've got 2 odd. This is definitely a path. See if we can find it. So let's start at B. And we're going to end at E. So I'm going to go down to D first. That's 1. Down to F is 2. Up to C is 3. Down to D is 4. Across to E is 5. Up to A is 6. Across to B is 7. Down to C is 8. Up to A is 9. All the way down to F is 10. And over to E is 11. Remember, we found out yesterday too. I can add up all these degrees. So A is 4, B is 3, that's 7. C makes 11, D makes 15. That makes 19. That makes 22. So I've got 22 total degrees. It's 22, which means half of that should be my amount of edges. I had 11 edges that I traced. So that's a good way to check yourself as well. Remember, the amount of edges in your graph should be half of the total degrees that you have. Okay. Graph 9. Almost there, guys. Okay, A has a degree of 5. B is 4. C is 3. D is 1, 2, 3, 4, 5. E is 4. F is 3. G is 4. I have 4 odd vertices here. This is a none. Okay, all have to be even for a circuit, exactly 2 for a path. So as soon as you see that third odd degree, you can shut it down. You're done. Okay. All right, graph 10. A has 4. B has 4. C has 5. D has 1, 2, 3, 4, 5, 6, 7, 8. E is 3. G is 4. And F is 4. So this is a Euler path. Okay, so we need to start at an odd, end at an odd. Let's go up to A. I'm going to go across to B. Remember, yours doesn't have to match mine as long as you traced and you started at one odd and ended at the other and traced all of the lines. Across to A is 3. Down to D is 4. I'm going to do this little funky looking oval thing over here. Here's 5. Back to D is 6. Back to C is 7. Down to F is 8. Up to D is 9. Down to G is 10. Across to F is 11. Across to G is 12. Up to E is 13. 14. 15. And finally 16. One more example for this lesson today. Graph 11. Whew, this one looks like a doozy. Okay, so we've got a degree of 2, 2, 4, 4, 4, F is 4, F, G is 2, H, 2, 3, 4, I is 4, J is 4, K is 4, L is 1, 2, 3, 4, 5, 6, M is 2, N is 2, O is 2, and P is 4. This is a circuit. Okay. So according to my rules, I must start and end at A. So I'm going to go down to B and up to C first, and then we're going to do all this fun stuff and hopefully end back at A here. So when I leave C, I'm going to go up to D. That's going to be 3. Across to E is 4. Back to D is 5. Down to E is 6. I'm sorry, F is 6. Here's 7. Down to G. 8 is I. H is 9. 10 takes me back to F. 11 takes me back to E. Let's go across to P, that's 12. Down to O is 13. Across to L is 14. Up to P is 15. Down to M is 16. Across to N is 17. Up to L is 18. Down to K is 19. Back up there. Let me not do that one. I've got to get this little loop here between H and L first. So let me go across to H is 19, back to L is 20. Now we'll go down to K. 21, up to I is 22, down to J is 23, back across to K is 24, up to J is 25, up to C is 26, and back across to A is 27. Now this one was huge, so let's make sure that we didn't miss anything. So A and B is 4, plus C is 8, plus D is 12, plus E is 16, plus F is 20, G is 22, H is 26, I is 30, 34 with J, 38 with K, 44 with L, 48 with P, 50 with O, 52 with M, 54 with N. So my total degree is 54, and half of that is 27. Okay. That's it for section 5.6. Okay, in your next lesson, we're going to talk about section 5.7, which is all about Eulerizing or semi-Eulerizing graphs. So we're going to take graphs that are not Euler circuits and make them into Euler circuits, and then we're going to take graphs that are not Euler paths and turn them into Euler paths. I will see you tomorrow.